All right, so in this lesson, we're going to talk about the volume of a pyramid and a cone. So first of all, let's talk about what a pyramid is. A pyramid is a prism that has triangular faces. Okay, so, I mean, you guys might know like the pyramid in Egypt. So that's a pyramid because all of the faces are triangles. So it has a triangle here, has a triangle here, has a triangle in the back, and it has a triangle on the side. Now the base can vary, so it could be a square, it could be a rectangle, the base could be a triangle, but what makes a pyramid is a prism with triangular faces. Okay. Now what a cone is, I know you guys have seen cones in your life at one point or another, is something that looks like this. It has like a circle on the bottom with like a triangle on top. Okay, so like an ice cream cone, a traffic cone, like a water cup, triangle. So you guys have seen cones a lot. So we're going to talk about the volume of cone and a pyramid in this lesson. Okay, so let's take a look at exercise 1. So we have a cube that has side lengths of 2 centimeters each. The center of the cube is located and segments are drawn to each of the 8 vertices of the cube. This creates a pyramid whose volume we're going to explore. Now, first of all, they want us to figure out what the volume of the cube is. So the volume of a cube is just length times width times height, okay? Or the length of the side cube, since we know all of the sides are the same. So the length of each side is 2, so 2 cubed is just 8 centimeters cubed, okay? Now, how many of these pyramids would fit into the original cube? Now, this is kind of hard to see, but we can actually fit 6 of them into this cube. Now, each side of the cube, so there are 6 faces in the cube, and actually, I mean, you guys can kind of see there's one pyramid on the bottom. Now, each face will be the base of a pyramid, and since there are 6 faces in the cube, 6 congruent pyramids could fit in this one huge cube thing. Okay. Now we want to find the volume of this pyramid that is in the cube right now. Now, since 6 pyramids would fit, we're going to take 1/6 and we're going to multiply it by the volume of the cube that the pyramid is in. So the volume is just 4 over 3 cubic centimeters. Okay. All right, so now let's talk about the volume of a pyramid. Now the volume of a pyramid formula is equal to 1/3 the volume of any prism. Now the volume of any prism is the area of the base times the height. Okay, so in this case, yes, the base was like a square, so it was length times width times height, and then 1/3 of that. But as I talked about before, the base of the pyramid could be anything. It could be a triangle, it could be a rectangle, it could be a square. So the volume of a pyramid is just 1/3 area of the base times the height. Okay. Now, as you can see on the bottom, there's like a few different types of formulas we have here. So this is just the volume of any prism, right? The area of the base times the height. This is the volume of a prism. So 1/3 the area of the base times the height. The volume of a cylinder, which is pi r squared times the height. Now, as you guys can maybe notice, pi r squared is the area of the circle. Okay, now the base of a cylinder is a circle, so this area of the base times the height thing kind of holds true for this one. Now for the cone, it is 1/3 pi r squared times the height. So it's 1/3 the volume of a cylinder, as you guys can kind of maybe see. So this is the volume of the cylinder, and for the volume of the cone, we just take kind of 1/3 of that. All right, so let's go to the next page. Let's look at some examples. All right, so let's look at exercise 2. So the Great Pyramid of Giza in Egypt has a square base that measures 756 feet on a side and a height of 481 feet tall. To the nearest million cubic feet, what is the volume of the Great Pyramid? Okay, so the height of the pyramid is kind of like the height of the triangle. The height of the triangle is this part, right? The highest point of the vertex of the triangle to the base. So same thing with the pyramid. The height of the pyramid is the highest point from the vertex all the way down to the base. Okay? Now the volume of a pyramid is 1/3 times the volume, the area of the base, times the height. Now, this pyramid has a square base. So the area of the square is length times width. Okay? So the volume is just 1/3 area of the base, so 756 times 756 times the height, which is 481. Now we're gonna go put this in our calculators. So the volume is just 1/3 756 times 756 times 481, which is that large number. So is equal to 9,163 272. Oh, I'm missing a number here. Sorry. So 91,636,272. Now we want it to the nearest million cubic feet. So we rounded this up. So 92 million feet cubed is our volume. All right, so let's take a look at exercise 3. So we have a cylinder of solid material with a radius of 4 inches and a height of 10 inches as a cone with the same radius and height removed from it. What is the volume of the remaining material? Now, when you guys get these types of questions, it's the volume of the shaded part that you're going to find is always volume of the whole thing. So the volume of the whole thing is the volume of the cylinder minus the volume of the inside stuff. So the inside stuff is the volume of the cone. Okay, so the volume of the shaded is, we're going to have to find the volume of the cylinder, which is just pi r squared times height minus the volume of the cone, which is 1/3 pi r squared times the height. Okay. So let's plug these numbers in and find the volume of the shaded part. So we have pi, the radius of the cylinder is 4, times the height is 10. Now 1/3 pi, the radius is 4, and the height is 10, the same thing as the cylinder. Okay. So let's put this stuff in our calculators. So volume of the cylinder is pi squared times 10. So the volume of the cylinder is 502.6548,246 minus this part. So 1/3 pi 4 squared times 10. 167.551608.2. So this minus this gives us the area, the volume, excuse me, the volume of the shaded part, which is just 335.1032164. Now we want to round to the nearest cubic inch. So we're rounding to the nearest whole number. So the volume of the shaded is just 335 inches cubed. Okay. All right, so let's look at exercise 4. So a pyramid is constructed from a cube shown below. Point C is the midpoint. This is important to know, of edge AB. So AC is equal to CB. If the cube has a volume of 216 cubic centimeters, then what is the volume of the pyramid? Okay, so we were given the volume of the cube, which is this. So before we can do anything, we need to find the side lengths of the cube. So we know that the volume of the cube is just the side length of the cube. So to solve for the side length, we're going to take the cubic root of both sides, so those cancel. So the cubic root of 216 is that. So 6 is equal to the side length. Okay, so this is 6, 6, 6. Okay. Now we want to find the volume of the pyramid. Now the volume of the pyramid is 1/3 the area of the base times the height. Now it's kind of hard to tell maybe, but the base is a triangle. Okay. So the area of the triangle, remember, is 1/2 base times height. All right, so the base looks like 3, and the height is just the side of the cube. Okay, so 1/2, 3 times 6. Now the height of the pyramid is the height of the cube, which is 6. Okay, so let's simplify this a little bit before we find the whole thing. So this whole thing is 1/2, 3 times 6. So 3 times 6 is 18, divided by 2 is 9. Okay, so 9 times 6 is 54, and then divided by 3 is 18. So the volume of the pyramid is 18 centimeters cubed.